Hi, I'm taking Paul McWhorter's AI for Everyone class, and we're on lesson 14, Understanding Contours in Opencv. So last week we were finding out how to isolate objects by color. So this week he was showing us how to find their position and size data on the screen so that we could use it for other tasks or whatever. So he gave us homework of using that data to actually move our window around the screen based on the position of the object in our frame. So we can get to the homework. It was fairly easy. First thing I did was not copied and pasted, but recreated Paul's contour code down in here so that we could create a rectangle around our object or get our contour X and Y and everything, so we could do that. So got that all done, and then just to move it around the screen, I only actually had to add 2 lines of code and a couple variables. So normally we put our window, we move our window to 0, 0 for our main screen. So I just create a couple variables at the top called WinX and WinY. And then I just, there'll be 0 when it starts out, but when we get to this if statement and we actually encounter contours data that we can use, it reassigns WinX and WinY to our X and Y of our contour rectangle. So bounding rectangle. So that was kind of fun. I had to multiply it by 1.5 so I could get the full coverage of going across and down the screen. And of course, we're only going to accept in our move window, we're only going to accept integers. So you have to make sure they're integers when you're doing that. But basically it was 2 lines of code and adding a couple variables. So we can see how it's going to work. So basically I got it set up to track this blue object. Just as soon as it picked up the blue object, it follows it around the screen. Like I said, getting a lot of, for 2 lines of extra code, you're getting a lot of utility out of that for moving stuff around. The power of computing, I guess. Of course, now you got to worry about, because you're queuing out of this, you got to make sure your cursor is actually over top of your screen. So I'm going to quit. There we go. So that was all the homework we had, but I decided to do a little bit more investigating on my own. I found this talking about contours. One of the resources I use is this opencv.org docs here, and there's a page on contour features. And if we go down, some of them I haven't investigated yet, but I figured I was looking at our bounding rectangle. So we have the regular bounding rectangle is what we're using. And then they have this rotated rectangle, which is min area rectangle, which was, I don't know, some of these I don't know where their usefulness would be, but I just found it and I decided to investigate it. This circle around it, min enclosed circle, if you want to follow the center of an object as you're going and use that data, The circle is probably a really good thing to do because that's what it spits out. It spits out the X and Y of the center and the radius of the circle that you're going to do. So I think that might be very useful in the future as far as like following a ball and recentering it in your, if you're doing physical computing along with it. Another one I'm not sure how you'd use, but I wanted to play with it, was this ellipse here. And then this is fitting a line. It kind of just tries to find a way to put a line along the longest axis of your best guess of your line along the axis. Anyway, I was playing with that, so I set up another code, basically the same thing. But I just decided to set up mouse clicks as a state machine. Each mouse click just increments through the steps of the states it can be in. And just in the while true, I just come down here when we get the contours. If we have any contours on the screen, it's going to look at whatever state it's in. So state 0 is our normal bounding rectangle that we used in the homework. State 1 is the min area rectangle. And like I said, I just basically copied the code that they had up there for just drawing these, and looked at the code and understood what it was doing. So that's always a good thing. I always like understanding how our code works. Then we do the same thing for the min enclosed circle. Like I said, that function is just bringing out the X and Y and the radius of that. So evidently the X and Y is not, that comes out is not in a integer form, since they're taking the trouble to turn it into integers. So and then they're just drawing a circle with the center and the radius. The ellipse code, it just turns the ellipse until you just whatever ellipse data you're getting is what you can put right into your ellipse function on CV2. And this last one here is the fit line one. I really don't understand all the code in that one, but trying to figure out what it does. This part up here, I didn't really find much information. I'm sure if I looked hard enough, I could find information on what all that is, but just didn't really know. I kind of figured out what they were doing in the code down here as far as finding the slope of the line that they needed to draw and everything. So anyhow, let's click through these, see what comes up. So, and we'll use our same image here. So we got just our rectangle. You can say this rectangle, depending on whatever it sees, it's going to give the outline rectangle. If we do a left click here, now we have the tilted rectangle or minimum area rectangle, and it just kind of follows whatever you got. And this is a circle, so circle, just you're changing the radius of the circle, but the center is going to pretty much follow whatever the white center is. Like I say, if you tilt it, your white center goes out, then some of your area might change a little bit like that, where you're not really in the center of your object anymore, but it's in the center of what it's detecting. So that's how that's working. And then the ellipse, like I said, the ellipse is kind of just not sure where we'd use that, but it's interesting. And it was, as far as code wise, it was nice and easy to implement. Not much typing there. And then the line, that's a little interesting. It does, most time it gives you a pointer to the long axis, but then every once in a while you'll get a crazy, depending on what your white mask is. As the mask goes crazy, then that goes crazy. But yeah. Not sure the usefulness of this either, because it really doesn't give you a good slope. Like you couldn't figure the angle of your object because it's really not giving you, unless you're perfect with your mask, it's not giving you a true line of it. So I guess if your mask is okay, if you concentrate on getting your mask okay, you can get the slope of a line. I wouldn't trust it personally. And another click will get us back to just our rectangle, and you just click through them. So just thought that was something interesting to investigate. So that's my homework, short and sweet this week. I want to thank Paul for all his hard work again, and look forward to seeing how he solved the homework, and looking forward to more lessons. Talk to you later. Thanks.